main objective of identifying the rock. Can you follow? So if you know the rock, then you will be able to predict their or its geotechnical and geological properties. So all these data are translated into geological design parameters. So you have to supplement your in situ natural outcrop characterization using drill samples. So of course, immediately after drilling, you obtain core specimen. So in the same way as rock sample, you have to characterize your core specimen megascopically, hydrogeologically, and geotechnically. Sometimes, after obtaining the core specimen, you lower geophysical probes. And for those who are currently taking applied geophysics, there are a lot of instruments which you can lower down the hole in order to measure several in situ properties of your soil mass and rock mass. This includes, among others, porosity, permeability, Poisson's ratio, shear modulus, and so on and so forth. Or you can scan your borehole electrically using gamma ray radiation, using sonic scanners, and so on and so forth. Or you can even lower a borehole acoustic televiewer, a camera, in order to examine the rock within the immediate vicinity of your hole. So collectively, this is called lithostratigraphic logging and borehole logging. So details about this will be discussed in another course, and that's geophysics. Then some samples will be collected for assay procedures in order to determine the metal content of your specimen. So if you're targeting gold, and of course you have to target indicator elements and pathfinder elements. I've mentioned this under prospecting. Okay? Subject it to mineralogical test or even additional chemical tests like what? AAS, okay, XRF, XRD, or electron probe microanalyzer, ECMA. Okay? So some of your core specimen will likewise be subjected to geotechnical core characterization following the ISRM standard. What is ISRM? ISRM stands for International Society of Rock Mechanics Standard. So there is a proper procedure to collect geotechnical data in your core specimen. And you can do field index tests or even elaborate laboratory tests in the rock mechanics laboratory on the ground floor. And you can also likewise measure several in situ, or rather intact, hydrogeological properties of your specimen. And if natural outcrops are present, then therefore you have to do scanline survey. Just like you in surveying, you lay out your traverse line. And at regular interval, you do exposure characterization, or you collect specimen, or you fill up geotechnical and geological forms. So there are standard forms which are available for use during the course of your scanline mapping. Okay? If you have underground openings, you can do drift mapping, right? Or cross-cut mapping. Likewise, using the principle of scanline survey to collect additional geotechnical and geological data. So samples may likewise be subjected to additional tests, mineralogical tests, petrographic tests, including geotechnical tests. So all these geological and geotechnical data are translated into design parameters. Can you follow? And design parameters are used, right, in what? What's the significance of a 3D model, assuming that you have already created a 3D model using an appropriate 3D geoscience software, like Micromine, Datamine, Gemcom, and so on and so forth. So you have to use this data in creating a 3D model. So what's the significance? Can you mention one significance of a 3D geotechnical model? In mining, what's the significance? Come again? If you're going to consider surface extraction or even underground extraction, what's the significance of the 3D geotech model?
Location.
Mr. Canares. If you have a 3D model, you can obviously visualize different geotechnical zones within your rock mass. And each zone now will have a unique geotechnical property, unique friction angle, unique cohesion, right? And it has unique what? Pit design and bench design. Some portions of your rock mass, no, may be designed optimally such that they are what? Standing at steeper angle compared to other portions of the rock mass. Why? For what reason? Because of variation in the property of your rock. You can see zones, no, geotechnical zones within your model, no? Strong zones, moderately strong zones, and weak zones. So you have various design on different geotechnical zones. In the case of underground mining method, of course, based on variation in the rock mass rating, right? And likewise, other engineering properties of the rock. So the mining method can shift from cut and fill to ratioing to sub-level caving, right? To shrinkage stoping and so on and so forth. Because one major criteria in the selection of underground mining method is what? Purely geotechnical criteria based on the Q value, or say based on the rock mass rating value or modified rock mass rating value. Remember? Diba? So that's the purpose. Other than mine design, other than pit design, bench design, and underground mine design, what else? Can you mention another significance, Mr. Tinga?
Glass design, space design.
How about in glass design?
Tama pala.
So you have different geotechnical zones, right? Diba? Zones with high rock mass rating, zones with intermediate rock mass rating, and zones with what? Low rock mass rating. Are you going to change the blast design for each change in your geotechnical zone? Of course, yes. Right? Blast design is modified based on what? The strength of your rock mass. And that is something that you can easily visualize in your 3D model. Right? So if you encounter low rock mass rating zones, so blast design is what? Different. Right? Diba? So you shift from one design to another depending upon what? The zones, no? Geotechnical zones. Other than that, what else? Yes, please.
Slope design.
Yeah, it was already mentioned earlier, slope design.
Okay.
You vary your what? Design based on your what? Geotechnical zone. You vary your underground mine design based on your what? Geotechnical zone. Right? And in the same way, blast design is varied with change in what? Zoning. What else? How about in the selection of what? Drill bits. Diba? Oh, pag matigas yung bato, low quality ba yung drill bit na gagamitin mo? Dapat hindi. Diba? So you know what drill bit to select. Huwag kang gagamit ng madaling mabungi. Alam mo naman na matigas yung bato. Tapos gagamit ka ng drill bit na madaling mabungi. So napakamahal nun. Can you follow? Isipin mo yung costs. So you have to do cost-benefit analysis. So the selection of what? Drill bits will depend upon